Hello, welcome again to Supply Chain Design course week 9 part 2. This session is about MRP or Materials Requirement Planning. Each of us buys sometime furniture which should be assembled at home, for instance from IKEA. As assistants, we get prospects which explain to us which items are contained in the package and in what quantity, how these items can be assembled, which items are necessary for sub-assembly, in which sequence we should perform sub-assemblies and final assembly, what time is needed for sub-assemblies and final assembly. You can observe from the assembly instruction that contain all of guidelines about how to assemble that particular product. In terms of operations management, we would describe this case as follows. We have got a bill of materials or BOM, and also we have performed materials requirement planning or MRP. From the example, we recognize that the demand for building a table depends on how many tables are needed. From IKEA perspective, a major distinction in the way inventories are managed result from the nature of demand for those items. When demand for items, for example here leg, sometimes knee or foot or top or skirt, is derived from plans to make certain products, in this case tables, as it is with raw materials, parts, and assemblies used in producing a finished product. Those items are said to have dependent demand. The parts and materials that go into the production of cars, for example, are examples of dependent demand because the total quantity of parts and raw materials needed during any time period depends on the number of cars that will be produced. In our case, the demand for leg, knee, foot, top, or skirt depends on the demand of tables. Conversely, demand for the finished cars or finished tables is independent. A table is not a component of another item. A bill of materials contains a listing of all the assemblies, sub-assemblies, parts, and raw materials that are needed to produce one unit of finished product. Thus, each finished product has its own bill of materials. The listing in the bill of materials is hierarchical. It shows the quantity of each item needed to complete one unit of its parent item. The nature of this aspect of a bill of materials is clear when you consider a product structure tree, which provides a visual depiction of sub-assemblies and components needed to assemble a product. Material Requirement Planning or MRP is a methodology used for planning the production of assembled products, such as smartphones, automobiles, kitchen tables, and a whole host of other products that are assembled. Some items are produced repetitively while others are produced in batches. The process begins with a master schedule. The master schedule designates the quantity and completion time of an assembled product, often referred to as the end item. Materials requirement planning then generates a production plan for the end item that indicates the quantities and timing of the sub-assemblies, component parts, and raw materials required for assembly of that n item. In this slide, there are three distinct items to be assembled. Turquoise rectangular stands for n items, modules that are produced in-house. Blue for the purchased components and pink ellipsoid for purchased raw materials. Codes such as COMP11 means component number 1 for module number 1. COMP12 means component number 2 for module 1. H11, 12, and 22 mean one raw material needed for one unit at an upper level. COM211 means component number 1, which is procured externally, is used by component 21, which is produced internally. The listing in the bill of materials is hierarchical. It shows the quantity of each item needed to complete one unit of each parent item. The nature of this aspect of a bill of materials is clear when you consider a product structure tree, which provides a visual depiction of the sub-assemblies and components needed to assemble a product. The end item or the finished product is shown at the top of the tree. Just beneath it are the sub-assemblies or major components that must be put together to make up the end item. Beneath each major component are the necessary lesser components. At each stage, moving down the tree are the components, parts, also materials needed to make one unit of the next higher item in the tree. A product structure tree is useful in illustrating how the bill of materials is used to determine the quantities of each of the ingredients or requirements needed to obtain a desired number of n items. Items at the lowest level of the tree often are raw materials or purchased parts, while items at higher levels are typically assemblies or sub-assemblies. Product structure tree for items at the lowest level are the concern of supplier. Looking at previous product structure tree, it is inefficient to be used in production planning and control. Therefore, in this slide, shows bill of material that simplify the description and therefore easier to read. In this figure, one n item needs each one module 1 and 2 module 2. Module 1 contains 2 units of component 11, 3 units of component 12, and 2 units of component 3. Module 2 needs 4 units of component 21 and 1 unit of component 22. Raw material 1 is needed by component 11 and raw material 2 is needed by both component 12 and 21. Component 21 needs 3 units of component 2211 and 3 units of component 22. Now, the question is that what does product structure restructurization implies? First, bill of materials represent a list of components, ingredients, or materials needed to make a product. Second, bill of material provides a product structure. After restructuring the structure, we have rewritten it simpler by depicting number of items required for one unit at the upper level. From the product structure, we can determine how many items are required at different levels of the bill of materials. We can see the table in the slide. We have different levels from 0, 1, 2, and 3. This is important to synchronize manufacturing and procurement since we can produce items at the upper level only after the items from the lower level are purchased or manufactured. While in level bill of materials, a component or materials can appear more than once in the table depending on at which level in assembly sequence the component or material will be used. From the product structure, we can also determine total quantity of all items. If we perform this procedure, we explode the bill of material. For the given structure, we can explode the bill of material as shown in this slide, and we can see that each items appear only once in the table. Example for material 2 or M2, 3 pieces are needed for one component 12. In turn, 3 pieces of component 12 are needed for one module 1, and one module 1 is needed for one N item. So the dependent demand on M2 or module 2 or material 2 is now 3 times 3 times 1 equal to 9 pieces. In addition, one piece of M2 is needed for one component 21, and 4 component 21 are needed for one module 2. Two modules 2 are needed for one N item. So the dependent demand on M2 is now 9 from the previous plus 1 times 4 times 2 equal to 17 pieces. With the help of bill of materials, the product structure is defined. However, manufacturing and procurement of items happens not immediately. This requires a certain lead times. For production, lead time is the sum of the order. Wait, move, set up, store, and run times. For purchased item, lead time is the time between the recognition of a need and the availability of the item for production. The lead time is taken into account to calculate MRP, and therefore, for calculating MRP, the following data are required: MPS or Master Production Schedule, BOM or Bill of Materials, inventory availability, purchase order outstandings or schedule receipts, lead or manufacturing times for each items. On the basis of this data, the materials requirement planning system On the basis of this data, the MRP system calculates orders for manufacturing and purchasing. MRP calculation is based on the following algorithm. From exploding bill of material, gross requirements on items are defined beginning with the upper level down to the lower levels. Taking into account inventory availability and purchase order outstanding, scheduled receipts, net requirements can be determined. An equation for calculating net requirement is that gross requirements minus inventory availability minus scheduled receipt. Finally, net requirements are used to determine the actual order release time subject to lead time. This step is often called lead time offset or time phasing. Let's take a look on the current example. The figure shows a bill of material BOM by assuming inventory is available and no scheduled receipts are planned. Now we go to this MRP computational result. Lead times for all items is 1 month. In this case, gross requirements equal net requirements, and we have the following table represents the result of MRP calculation. We start with the net requirements for an item. This data taken from the master production schedule or MPS. The next step is to determine net requirements for the items at the first level. Since for all items, exactly one piece is needed for one end item. We can see it from the previous slide here. One item needed exactly one by an item. Therefore, their net requirements of components A, B, C, and 1 are identical to those to the n item. Net requirements for the items at the first level should be shifted according to 1 month of lead time, meaning that items A, B, C, and 1 must be available 1 month prior to the delivery of an item at each delivery periods in month 4, 5, 6, and 7. And therefore, it is shifted from left to right at 1 month. Similarly, net requirements for the items at the second level are determined subject to net requirements of the items at first level and lead time shifting by 1 month. Right? In the level number 2, we have here should be shifted 1 month to the left. Alright? We have B, D, 1, 2, and 3. B, D, 1, 2, and 3. 1 appear twice here. Alright? And therefore, the demand for E, an item E, is 10 for April, and therefore A should be available 1 month prior to the delivery of E at 10. So we can see here at 10, right? Here 10, 10, 20, 20, 50, and 50. And for component number 1, for each A needs 2 component number 1. And for each B need also 2 for component number 1. And therefore, for each n item E need 2 plus 2 equal to 4. And therefore here we have for component number 1, it's 40 because the demand is 10 for April, and therefore 2 months prior to April, that is in February, 1 is needed at 40 items. Alright? Similarly, net requirements for the items at the second level are determined subject to net requirements of the item at the first level and lead time shifting, as I mentioned before. For instance, 20 units of item D in period 2 means that we have to manufacture 20 units of item D in February in order to be able to assemble 10 units of an item E in April. Because the demand for D is 2 times 1. Because E in April, the demand will be at 10, and therefore the demand for D in February will be 1 times 2 times 10 equal to 20. By processing the bill of materials by level, items with multiple parents are typically only processed once, saving time and resources and reducing confusion. We transform the current table as the next table. The above transformation is based on aggregating the net requirements of the same items over different levels in each period. For example, in period number 2, we aggregated net requirements for item 2 from the second level, that is 30, and third level, that is 80. Net requirements for item 2 in the second period is 110 pieces. This information is important for purchasing planning for February. Now we have another example where we have inventory at the beginning of planning. We have here table of master production schedule in our slide. Lead time for the table production is 1 period. To produce one table, we need 4 legs and 1 plate. For tables, you have got additional demand of 25 units in period number 8, 10 units in period number 9, and also 10, period number 10. We have 35 tables, 25 plates, and 32 legs as beginning inventory. The retailer announced that it will send back 7 tables in period 8 and 5 tables in period 10. For plate production, we need 2 periods. In 1 period is needed for leg production. Now we are going to include inventory and schedule receipts into consideration, assuming the following problem statement. Okay? Lead times for the table production is 1 period. So to produce 1 table, we need 4 legs and 1 plate. And for tables, we have got additional demand of 25 units in period 8, 10 units in period 9 and 10. And therefore here we have 4 tables, right? We have 25 additional period, 25. We have 10 for period number 9 and also number 10. Okay? We have 35 tables, 25 plates, and 32 legs at the beginning of the plan. And therefore we have here 35 tables, 25 plates, and 32 legs at the beginning of the planning period. Alright? The retailer announced that it will send back 7 tables in period number 8, maybe because of some damage or return from customer. And the manufacturer received back from retailer at 7 tables on period 8 and also 5 tables in period number 10. Okay, and we assume that these tables can be remanufactured or refurbished. As our previous slide mentioned, for plate production we need 2 periods and 1 period is needed for leg production, and therefore the plates must be available 2 months in advance prior to manufacturing of one table. Also, same case for legs, that is 1 month prior to the delivery of tables. First, we perform calculation for tables lead time equal to 1, alright? Here we have the total demand, that is equal to demand plus additional demand, that is 150. Similarly for month 9 and 10, just add 90 with 10, we have 100, 110 plus 10, we have 120, right? Because we have on-hand inventory and schedule receipt at 7, and therefore the net requirement equal to 150 minus 35, that is 115, minus 7. So we have 110 net requirement, meaning that we have to manufacture tables at 108 pieces of tables. Alright? Similarly for months 9 and 10. Okay? Now we go to plates. For ordering plates, table manufacturer needs the plates available when the manufacturing of table started. That is at week number 7. Therefore, gross requirement for plates are equal to net requirement of table by shifting the gross requirement 1 month at month number 7. However, for case of legs, it need to be shifted only 1 month prior to the table production. But for plates, it needs to be shifted 2 months prior to the table production at week number 7. The gross requirement for plates is at 108. We know from our problem that the on-hand inventory for plates at week 7 is 25 plates as beginning inventory. And therefore, the gross requirement minus on-hand inventory result in net requirement. 108 minus 25, we have 83. And this 83 will be ordered in week 5, and therefore at week 7, when the manufacturing of tables started, these plates are ready to be attached or to be assembled with legs, right? For legs, the gross requirement is 432. Where it comes from? It comes from 108 times 4, because one table needs 4 legs, and therefore we have 432. But the on-hand inventory, according to the previous problem statement, 32 legs, and therefore the net requirement is 432 minus 32 equal to 400. And this 400 should be ordered 1 month in advance. That is in month number 6. Okay, that example ends our lecture today.